Hello everyone. Today we're speaking with co-founders of XproEM, Kinnor, Chattopadhyay and Brett Liu. XproEM has developed proprietary technology for recycling lithium-ion batteries in an economical and environment-friendly manner. And in this interview, we aim to learn about the tech and XproEM's business plans. So welcome, gentlemen. Pleased to have you both for this chat. So please tell us, what is XproEM's offering in the lithium-ion battery recycling space?
Yeah, well, again, good morning, Priyakshi. Thank you so much for having us. Right. So, as you rightly mentioned, XproEM is in the lithium-ion battery recycling space, and our main objective is to create a disruptive technology in the lithium-ion battery recycling space, whereby we are able to basically recycle all types of lithium-ion batteries in a more sustainable and environmental friendly fashion, and that too at offering better economics for the process. So that's really our mission statement, and we want to strive by that.
Right. But what is it about your technology that makes it better than the prevalent technologies for recycling?
Right. So you see, if you look at the overall lithium-ion battery recycling space, majority of the processes which are commercial or going to be commercial are mostly based on hydrometallurgical techniques, right? Now, of course, hydrometallurgy is a very established technique. It's a very good technique. But one of the challenges is that it uses a lot of, acids, bases, organic solvents, and water. Then you have lots of volumes of wastewater generated, right? Then you have to treat that wastewater because of environmental regulations. So one of the things, the reason we came up with the disruptive idea is we want to do this whole LIV recycling thing in solid state. So instead of using any acid, bases, and wastewater treatment issues, we try to convert these batteries in solid state by using a solid state reduction scheme. And through this process, what happens is our process flow sheet is shorter. So that means the capex requirements are lower. We don't have to treat wastewater as much. So our cost of all these operating costs become lower. And at the same time, because this process is happening in solid state, we are not melting anything. So we also have lower energy consumption. So all these together make the process unique, and we believe that will be the way forward eventually when environmental regulations become very strict.
Okay, so in terms of technology commercialization and technology readiness, where are you? What is the current status?
Yes, so we have basically done all the validation part that needs to be done for this technology to be now going into the demonstration level. So we have finished all the preliminary engineering design work for setting up this demonstration plant. So now we are at a stage, we are just working with different partners and we are ready to set up a demonstration facility where we are looking to at least process 1 to 2 tons of batteries per day at this stage. And then once the demonstration stage is done, then we can go into like full scale production and full scale commercialization.
Right. And where is this demonstration facility going to be set up?
Right. So just to give you a bit of background, XproEM is a Canadian company, right? Incorporated in Ontario. So that's where all the innovation work has been done, and the patents have been filed in the US, along with patents corresponding international applications in China and India. But of course, you understand, for this process to be viable, you need a steady supply of raw material, right? And we believe that can only happen in India and China for now, because that's where the EV booms are happening. So our demonstration plant, we are looking to work one with the Chinese partner to set up in China, but we are also working with we're discussing multiple partners in India to set up a demonstration facility also, probably in the NCR region in India as well.
All right, right. So in terms of market focus, you are planning to start in China and India, though the technology has been developed in your Canadian facility.
Yeah.
All right. So specifically for Indian markets, what are your plans? How do you plan to proceed from your current position?
Right. So you see, I mean, of course, in India, there are also many local players in different parts of this value chain, right? So we are engaging with different partners, starting from, people who can collect the batteries, people who can produce, partially process the batteries. So we are trying to work. What we believe is, we believe in inclusive growth. So we want to involve partners together with us. And we are looking in India, to basically work with multiple partners because it's a big country, right? And that way we should be able to reach the full geographical extent and be able to offer our services all across India, right? So I mean, if you ask for one specific answer, yeah, we want to work with local partners in India to commercialize this and take it forward.
Apart from the people who will help you with the collection, what other kind of partners are you looking for?
So we are also looking for people who are already in the traditional battery recycling space, like those who are doing lead zinc batteries. So we are talking with them. We are also talking with people who might be looking into cell manufacturing with these PLI schemes announced. So they would be interested in the material we would produce after recycling. So we are having all these discussions at this stage.
Okay. Right. So
yeah.
Go ahead.
I would just add one point to it. So recently, there has been some, I wouldn't call concerning trend, but definitely something caught our attention lately, because we have foreseen this a couple years back, but it's happening now, which is basically people are start recognizing the value, potential value trapped in the spent battery. So recently, just after speaking with our partner in China, we understand that this just by purchasing or acquiring a spent battery in China, the price has gone up quite a bit lately. And what this does is that it started to push pressure on the processor of the battery, because if you acquire this at a higher price, then you have to go through your physical separation, right? Then you have to go to your chemical separation to get the valuable component out. So the entire value chain becomes squeezed. This is similar to the EV boom 5-7 years back in China. What happened there is that it was also very hot and concentrated market, but what is more valuable for that value chain is the raw material. So what happens is that all the miners or all the commodity traders who traded on cobalt, lithium, they own the resources, so they were making a fortune out of it. But downstream from that, whether it's the cathode producer, precursor producer, or the battery manufacturer, even the car manufacturer, they are facing just increasing pressure on their bottom line, on their margin at each level. So what we know for a fact is that any of that middle chain player, I will call them that, they have a margin no greater than 20% gross margin. So that's why it was at a time when there was more than 200 battery makers, cathode makers in China. Now it's probably 30 major left. So that was a brutal screening process to screen out all those ones with poor economics, without scale, and with outdated technology. Right. So we fear this might be the case for the recycling world, but then I think the fear just become reality this year. So the price for the raw material gone up for the feedstock, and also the wastewater regulation in China from again, this is from our partner, is also becoming increasingly tight. So a lot of places you're not allowed to charge a single drop. You had to be fully recycled. And what does this to the hydro player is that the hydrometallurgy, the amount of water effluent had to be taking in and out of the plant is a humongous, right? There's no denying that. So to recycle that amount of water and reuse, then the cost should be, power or equipment or like manpower. It's adding to the already poor economics of the hydrometallurgy. So and this is the challenge was there. We kind of see that 2 years ago, but it's still and it's happening very recently now. So I think this is speak to one thing to us is that we need to speed up too, and but our solution is also desperately needed for those middle ground player trying to find something to help their margin, right? If someone can help lift their margin, there's just more supply on the table and nobody have to scrap, because right now it's just not enough. You know, you can't sell, because the downstream process is pretty regulated, right? Like if you want to sell your cathode, recycled cathode, you had to compete with the ones coming right off of the mine, and then you can't just say, oh, because I'm recycled, I'm 20% more expensive than you, and you had to take it. No, nobody's gonna take it, right? And if the battery price cannot be regulated and it had to be, you know, just set by itself, then all this middle value chain player, they had to find a way to help themselves, and we believe we stand a good chance helping them.
Okay.
So yeah, I think just one thing I want to touch on, but on the you know, Indian focus and what's happening, you know, in relation to the rest of the world, and how the market is moving, and this is happening in India too. What we understand is that, sorry, just give me a second. You know, go ahead.
Yeah. So I think what I was basically, I mean, what Brett was saying is that we got a lot of learnings from China, right? And we believe because India also has a huge volume of EVs coming in, right? And environmental regulations are getting stricter. There's a lot of learning we got, and we are basically going to, you know, apply some of those learnings in the Indian market as well.
Like how Brett pointed out, economic viability of these operations is a major concern.
It's a major concern.
Yes, and another concern that we see is, you know, with increasing penetration of the LFP batteries, there is always this concern that the constituent materials are not as attractive economically. So what is your comment on that? How does your technology help with LFP specific recycling?
Right. So you are bang on. I mean, for LFP batteries, going for the full-fledged recycling is not economical, right? And perhaps because it doesn't have nickel and cobalt, it will never be economical. So for LFPs, actually, XproEM developed a proprietary technology called the diffusion-driven doping restoration process, or the D3R process. And in this process, what we do, instead of trying to recycle the battery, we are basically trying to restore the cathode and the anode, right, directly. So what happens in this way is we basically go through a process and we are able to restore the electrical properties of the cathode and the anode to almost 90% of the original electrical properties. And then those can be used pretty efficiently back into a new battery pack. But in this way, what happens, the process now becomes economical because we are not looking to extract the nickel and cobalt because there is no nickel and cobalt, right? Yes. But the restoration will make the process more viable. So you are correct. The economic viability is the key concern. And then for LFPs, the strategy has to be completely different.
Right. Understood. But for the other chemistries like NMC or NCA, your other processes will be relevant, right? Yeah.
So whenever it comes to ternary batteries, right, which has these precious metals, then our S3M process, which is our solid state subtractive metallurgy technology, that is going to work, because there we are looking to actually extract the material and then sell it back into maybe the supply chain somewhere.
Right. So do you have any projections on when you supply the recycled materials versus the virgin material that is being collected from the ores and refined? What kind of price differential can we see? Because ultimately it has to make sense on price, right? So what kind of price advantage can a cathode manufacturer or an anode manufacturer get from there?
So look, I think one of the things is when you mention about price, I think these prices of the raw materials are pretty much determined by the market, right? So, I mean, we have to stick to that. But where the recycling process helps is if you look at a country like India, which doesn't have abundant resources of these critical materials, right? So we are relying on imports, right? And I think that's where recycling becomes very important, because then you can set up a local, circular economy where you can, recycle these used batteries and then use it back into your value chain, rather than depending on importation. And we know how importation affects, because we are a country which needs a lot of energy, and we are already dependent for oil and gas, right? We are importing that. So I think with critical materials, if recycling can become viable, it can at least offset that risk of like heavy reliability on imports, right? So,
Right.
so I think that is becoming a more important issue than the price part, because price will be depending on the market. And
Price, yeah, I'll just give some also background on how the pricing and what's the percentage of recycling versus the you know, the ones coming from the mine. So at this moment, from the critical metals, recycling probably comprise of no more than 5%. I would say on the single digit, lower single digit of the entire cathode anode probably none, honestly. Cathode probably lower single digit. So what is the potential for the recycling to be in terms of supplying the critical material? We expect by 2030, it could go up as much as 20% if the regulation helps and if the players are growing the way they are right now. So it is small, still small compared to the material coming from the mine and the manufacturing. So we see recycling as disruptive from a technology perspective, but from a market pricing, we're just going to take whatever the car makers or the battery makers going to pay for us. Because if that's good, then no, we shouldn't be shying away from that, right? Because that's going to help our margin. Yeah. I mean, we could lower that a little bit eventually to be competitive, but that's not healthy. The good competition happens when the price is set by the market. So we don't want to be just compete on the pricing side. We want to compete our technology side where we lower our margin internally. Or lower our cost internally and help our margin up. But the top line is whatever the market give us. So I think that's the underlying logic. So I think back to Kinnor's point, I mean, India needs a lot of this material down the road, and if the pricing happen to be somehow favorable for us or for the recycler, I think that's also a good incentive for people to work on this.
Okay. So for anybody who is looking to set up a brand new lithium-ion battery recycling facility, so they have to stick to one of the processes, right? It could be hydrometallurgy or pyro, or it could be your technology. So in terms of setting up a new recycling facility, how much simpler or more affordable would it be to go with XproEM's technology?
Right. So like I was mentioning to you in the beginning, I mean, we are trying to achieve our recycling goals using a solid state technology, right? So what happens is, because we are doing a solid state technology and we are not using a much wastewater treatment, our process flow sheet is more concise, right? So that helps you in, firstly reducing the capex of the project, right? So what we have seen is, with our calculations compared to other technologies, our capex can be almost 40 to 50% cheaper compared to the investments required for other technologies. Secondly, because we don't have to do the wastewater treatment, our consumable costs are down because we are not adding acids and organic solvents and so on. And at the same time, we are not melting anything because everything is done in solid state. Our energy consumption is low. So our operating cost is also almost 50 to 60% cheaper, right? Okay. So that way, we also believe that, like Brett was mentioning, for intermediate players, I think our technology can become very attractive, because that will help them get higher margin from their operations, right? Right. So absolutely. So like you said, I mean, sustainability is very important, but at the end, everything has to be driven by economics. Yes. So we believe that our technology also offers that economic advantage.
Right. So I think that's all the questions we had. But if there is anything else you want to highlight about your technology or your business plans, you're welcome to do that.
Right. So I would just say that we have been very happy that we are able to engage in the Indian market with different players. So that gave us enough motivation, to file our patents locally in India. So we just finished that process, right? And we are also setting up XproEM in India, right? So that process is also almost finished. So we are very excited, to work with more players in India and try to bring this, and hopefully that we can actually sustainably recycle LIBs locally in India and help the local supply chain.
Okay. Thank you, gentlemen, for your time, and I wish you the very best with your plans for India and, of course, globally. Thank you.
Thank you so much, Priyakshi, for having us.